Look at it, a thing of beauty. We're going to get this thing fabricated. A great sanity check is to first print in one-to-one. So open up the print dialog, and you want to print in general like the front copper layer, the front silk screen, and the edge cuts. Make sure the scale is set 1-to-1. That's super important. When you look at the print preview, you'll see what's going to come out on the page. So go off and print that and make sure that all your components fit. Do your best not to skip this part because it can save you a lot of heartbreak later. So the service I'm going to use for this video is PCBgogo. There are plenty of other PCB manufacturing services. JLC PCB is another good one, PCBway, Easy EDA, there's so many services. And the good thing is they've all basically standardized around looking practically the same on their order form. Before you export your KiCad files, I would first recommend you Google the name of your manufacturer and then KiCad export, because every manufacturer ought to have their desired settings that they'll just hand to you. And that can just improve the reliability of the export-import process. This is the very sparse instructions from PCBgogo. They basically say export everything. If you are working with JLC PCB, then they would have much more comprehensive settings for you to follow, like their desired layers and all the general options that they would like you to set. So whatever manufacturer you choose, just give a first pass over what they would prefer as their input. Let's export the Gerbers. We've already passed the ERC and the DRC, so I'll go up here to the plot tool. I'll select an output directory. I'll create a new folder called Servo Controller Gerbers. I'll use a relative path. Front copy yes, back copy yes. Adhesive is for advanced fabrication, don't worry about that. Front paste yes, back paste yes. These are often needed just so that they know, even though they're empty, or even though we're not maybe getting a stencil, they know that they have a complete job. There is no files missing. Front silk screen yes, back silk screen yes, mask yes. We don't need anything user unless you want that to appear somewhere, or unless you have specific instructions. Often user comments or user drawings are used to issue further instructions to the fab house. We won't need those. We definitely want edge cuts, and that's it. So we basically want all the copper and the board outline, the mask, the silk. I'm going to turn off print footprint values. The nice thing about the reference designators, that's all these R1s, R2s, is that you can update these values on the schematic and you don't have to update your physical design. So you may be tempted to print the values on the board, but later on you may decide that the circuit works better with different values. So it's more helpful to just print the refs, leave the values out. That's an opinion, but it's how a lot of people do things in industry because it makes it much more sustainable and scalable. We don't want to force plotting invisible stuff. Definitely check the zones before plotting. That refreshes our copper fill. If there's any changes that get made, we definitely want those to be updated. And the rest of these options, PCBgogo doesn't seem to have much to say about that. Just to include the extended attributes. And this is from years ago when KiCad was in a much earlier version. So I'm just going to leave the rest as defaults and we'll see how we go. We'll plot. That creates a plot of all the layers. The drill files, we want to leave it in exactly the same place. And the defaults here are probably what they're going to want. So we'll use the route command, absolute origin, because we used the absolute origin in the first window, except here it's use drill place file. So that's when this is unchecked, we're using absolutes. Drill units, I think millimeters is generally preferred by industry, and decimal format recommended. Let's go with that. I'm going to generate the drill file, and I'll generate a map file too. We've generated Gerbers, which are essentially snapshots of every single layer that make up the PCB. It's always a good idea to sanity check the Gerber files. From the main menu, click the Gerber viewer, and then click the File Open button. We'll open the Gerbers, and I'll just select everything and click Open. It's failed to load the job file. I shouldn't have selected the job file anyway. But here we have the whole Gerber stack up. We don't have the drill files. We do have the drill map files, but to open the drill files, go to the next button over and select to open those .drl files. And this is literally the fabrication information that you're going to send to the manufacturer. So I'll hide all layers and just step through them one by one. I'll start from copper. This is our bottom copper. That looks about right. We've got our bottom mask. This is where there will be solder resisting mask. And yes, there should be a cutout over every hole. We don't have anything on the bottom paste. That's correct. The bottom silk screen, I just had my name with the year. The edge cuts looks good. The front copper looks good. The front mask looks good. Front paste looks good. This is a good one to check. These are all our surface mount components. So if we got a stencil made up for applying paste to all the surface mount pads, this would be where there would be apertures in that stencil. So this is pretty important. Does it make sense? I'm looking for red pads here, and these are all the red pads. So these are the only things that are going to get paste, and that's what we have here. We obviously don't want paste going into the holes. We'll cover, if you don't know what paste is, we'll cover that later. That's more of an advanced assembly technique, but it's still well worth learning. So we're going to get solder paste applied to all these red pads. That looks pretty good. Silk screen. This is a great clean view to just make sure that all your silk screen at least exported as you expected, especially if you include custom artwork, which we'll cover later as well. We've got the drill map. This is just telling us the types of drills that are going to be used, and importantly, these are all the non-plated holes. So here we are at PCBgogo, our fabrication service, and the first thing to do is add a Gerber file. I'm going to right-click my whole Gerber directory and create a zip, and then upload the zip. This is a pretty standard way to ingest Gerber files onto a website. And because this is a small board, it's automatically rendered a 3D preview. You can see the top layer and the bottom layer. The board is shown from two directions. And interestingly, we can see that we have the copper fill on the bottom layer and no copper fill on the top. That's totally fine. We're going to proceed with normal FR4 board. We have a single design and a single size. We have a minimum order of 5 units. We don't want any panelization. That's an advanced fabrication technique. I'll leave the FR4 selection as the default, the thickness 1.6 millimeters as the default, the minimum track spacing. It seems like they can operate with different tolerances, different minimum tolerances, probably for quite a jump in fee. Solder mask we'll leave as green. You can select one as you like. The silk screen you can get in different colors. White is the default and the cheapest. The surface finish. I would encourage to go hassle lead free. Hassle with lead means you'll be soldering with lead. Hassle lead free is probably something to shoot for more for industry. You're reducing the amount of toxic materials in the environment. Tenting vias, yes. That just covers the via with solder mask so you can print over it. 1 ounce copper, yes. PCB assembly, no. SMD stencil. This is where our paste layers came in. And if I pick yes, it means that we may get a SMD stencil to build this PCB with. For now, I'll select no. I think most people will go with no in general. Nominally, we don't need any PCB assembly because that's pretty expensive and our board's pretty simple. So you can click calculate. 24-hour build time with no extra fee. Oh, they'll add the logo to the board. Whatever, that choice is up to you. Find the shipping options. And there you have it. You have a PCB design in your shopping cart that's ready to check out. You can check out, fill in all the address details, and your board should arrive, I guess, in about 2 weeks. Now, if you're using a competitor's service, pretty much any service you look at will have a very, very similar look and feel. This is JLC PCB. which is a service that I've been using for a while, and it has pretty much the same options arranged in the same way. You add your Gerber files as a zip file, select your material. It'll often preload the dimensions if it can figure them out, and then you just have, look, you have pretty much the same options all the way down. You know, you've got the standard PCB specifications like PCB color, silk screen, the surface finish, and then, you know, more expensive options. And then in a similar format, you have options for PCB assembly, and you have options for a stencil. And so that is pretty much the last step to getting a PCB made. Once you click that go button, your PCB will arrive in the post in a couple of weeks. Now, you don't have to do this for this short course. We will have some PCBs available for you to assemble that look pretty similar to what we've designed. I'm going to take this design and add some quality of life features to it that would have really bogged down the essentials videos in this course. But if you're very keen to get your own PCB assembled, then of course you could go ahead and do that. This is the final step. From here, the only things left to do is to assemble the physical PCB. So join me in the following videos where we'll go through commissioning the physical PCB and seeing if it works.